Hello everybody, welcome back to our interesting mathematics class. This is Abdul Karim Vahaj, one of the mathematics instructors in these high schools. Today I'm going to talk about the advanced general term of geometric sequences. As you know, we have studied the general term of geometric sequences in the previous lessons. Today I'm going to focus and I'm going to talk about the advanced general term of the geometric sequences. Okay, dear students, first of all we must define what is that. The general term of a geometric sequence like Rn with a common ratio with r is equal with in is equal with ap times r to the power of n minus 1, n minus p. Okay, dear students, if I put instead of p is equal with number 1 on the term, this formula will be changed into general term. Like n is equal with a1 times r to the power of n minus 1. This is called the general term of geometric sequences, which we have talked before in the previous lessons. Okay, dear students, according to this formula, we can find the required terms which the example one says we can find easily. Okay, the example one says, in is a geometric sequence with the eighth term is equal with log of 25 to the base 3 and the fifth term is equal with log of 5 to the base 3. Then find the common ratio. To finding the common ratio, we can use easily from this formula which is given to us in the advanced general term of geometric sequences. For this reason, if I substitute in is equal with the 8th term, which is given to us log of 25 to base 3, and AP is equal with E5 is equal with log of 5 to base 3. Here, first, how we can find the common ratio? On the time, I can use AN over AP is equal with R to the power of N minus P. Here, N is equal with the number 8 and P is equal with the number 5. And this is very easy. Just we will substitute here log of 25 to the base 3 over log of 5 to base 3 is equal with r to the power of n is equal with the number 8 minus what? Minus 5. Here I can find log of in the, be attention there students, this is one of the base changing properties which we have studied in the logarithmic parts. On the time I can write this one in the simple form like log of 25 to base 5 is equal with r to the power of 8 minus 5 will be r to the power of number 3. Here I can write the 25 to the base, according to base 5, on the time I can write log of 5 squared to the base of 5 is equal with r cubed. Here, every logarithmic number to base itself will be number 1. On the time I can write the instead of log of 5 squared to base 5 is equal with number 2 is equal r cubed. Here I can find the rational r is equal with third root of number 2. It was easy, dear students, and let's check another example. Like it says in a geometry sequence like Rn, the 9th term is given to us is equal with 32 and the 12th term is equal with the number 4. And then the required term which we want to find in this example is the 5th term. Here, how we can find? First, we must find the common ratio. On the time, how we can use? According to the given example, like Rn is equal with the 12th term is equal with number 4. And AP is equal with 32 is equal with AP is equal with the A9 is equal with 32. Here first to find the A5 on the time it is necessary to find the common ratio first. Here we can find AN over what? N minus P AP. Here I can find N is equal with the number 12 minus P is equal with the number 9 is equal with AN is equal with what? Number 4 over AP is equal with 32. Here when I simplify 4 over 32 on the time I will have 1, 4 and 8, 4. Here r to the power of 3 is equal with 1 over 8. And when I simplify this one, or when I take the cubed root from both sides, and the time r will be equal 1 over number 2. And now I found the common ratio, then it is necessary to find what? The fifth term. The fifth term is also used from the given terms. For example, when I use a9 is equal with a5 times r to the power of 9 minus 5. It is easy. a9 is equal with 32. a5 times r to the power of, and we could find the number r also. 1 over 2 to the power of 9 minus 5 will be 4. Here 32 is equal with 8 times e5 times 1 over 2 to the power of 4 will be 1 over 16. To finding the fifth term, it is necessary to multiply both sides with the 16. On that time, when I multiply with 16, on the time I will have e5 is equal with 32 times 16 will be 520. This one is equal with the fifth term. Okay, dear students, it was easy. It is very easy to finding the fifth term or the required term with the given with the given formula, which is advanced general term of arithmetic sequences. Okay, dear students, let's check another example. Like in a geometric sequence like an, the fifth term is equal to 3 to the power of 4 times x plus 7. And the ninth term is equal with 3 to the power of 8 times x plus 11. On the time it wants to find the 21st term. Here, as I solved in these two questions, in these two examples, it is necessary first to finding the common ratio. Like how I can find. Here, for example, EPS is equal with A5 is equal to 3 to the power of 4 times x plus 7, and En is equal with the A9. E9 is equal with 3 to the power of 8 times x plus 11. Here first we must find the common ratio, then we can find the A21. Here to finding the common ratio, r to the power of n minus p is equal with, here I can find Rn over Rp. Here, Rn is equal with the 3 to the power of 8 times x plus 11, and Ep is also clear to us. 3 to the power of 4 times x plus 7 is equal with r to the power of n minus p. N is equal with the 9 minus p is equal with number 5. It is equal to r to the power of 4. Here, it is necessary to simplify according to the exponential properties, and then we will find the common ratio. R to the power of 4 will be 3 to the power of 8 times x plus 11 minus 4 times x minus 7. Here, 3 to the power of 4 times x plus 4. Here, this is equal with r to the power of 4. When I take the fourth root from both sides, on the time r will be equal to 3 to the power of x plus 1. This is the common ratio. And now this is easy to find the 21st term. A21 over, for example, A9 is equal with r to the power of, for example, 21 minus 9. Here, A9 is equal with, A21 is equal with A9 times r to the power of 21 minus 9. Here, A21 will be, A9 is equal with, what? A9 is equal with 3 to the power of 8 times x plus 11 times r to the power of, r is equal with 3 to the power of x plus 1 to the power of 21 minus 9 will be 21 minus 9 will be 12. Here when I simplify, or when I multiply two terms which the bases are equal together, on the 10 just I will add the powers with together according to the exponential properties. Here E21 will be 3 is 3 to the power of 8 times x plus 11 times 3 to the power of, the power will be multiplied with together. 12 times x plus 12 is equal with 3 to the power of 8 times x plus 11 plus 12 times x plus 12. Here I can find 3 to the power of 8x plus 12x will be 20x plus 11 plus 12 will be 23. This is the required term which the example wants as 3 to the power of 20x plus 23. This is the example which wants us to find from us. Okay, dear students, if you have any question, if you face any question, if you have any best suggestion, if you have any best comments, we are waiting on our YouTube channel of Afghan-Turk Maarif High Schools. And not forget to subscribe our channel. Thank you for your watching.